Good to be with you today. Can you hear me okay? Yeah, good. All right. So I work at NBC. I'm the director of data science, one of many directors of data science, but I work in the NBC digital division. So that's the division that produces the NBC.com website and the NBC app, which is available on a lot of platforms. And a lot of our shows are also on Hulu, and a lot of you might watch our shows on Hulu. But for people that don't want to pay a Hulu subscription, the NBC app is free. And even without a cable subscription, you can usually watch the shows if you wait like a week after they air. So it's paid for by commercials. So let me tell you a little about our first algorithmic recommendation engine. So when I joined the company about almost 2 years ago, one reason that I was really drawn to work there is I had always wanted to work on a recommendation engine. So Netflix, Pandora, I was just fascinated. I have a background in psychology, so I was fascinated. How did these systems figure out my psychology of content just by looking at what I do? You know, I watch a couple shows or I listen to a couple of songs, and wow, somehow it knows like what I like, and I didn't even tell it what I liked. And so that is what really drew me to NBC, because they hadn't yet built one. And I was like, well, I'd like to come build you one. And so luckily, a friend of mine was there and was able to get me on board. And so I've spent the past year basically building this. We released it 3 months ago. We just got the quarterly results. I'll talk a little bit more about that. And I can't go into too much detail, but I will tell you it's our #1 feature on our app and site for driving episode watches, so people watching full episodes of shows. So it's been a big success. Which is not surprising to anybody in the room that's familiar with collaborative filtering. It's probably more surprising that NBC didn't have one right at the time. So it's been a great success. It's been a lot of fun. And it's really about getting users to watch more Days of Our Lives and Dateline, because at the end of the day, that's what most people do on our app. We'd love for them to come and watch like This Is Us and other shows, but our #1 shows are the ones that are only on the app, things like Days of Our Lives, Dateline. I think we're exclusive on Blacklist as well. So it's on all the major platforms. You may be surprised how much content is there. Much of it is free. And we have a number of popular shows. Many of you probably watched this show. This is our #1 show by far and away. This Is Us. Very good show, coming into its 3rd season. We also have Superstore. Does anybody here like Superstore? That's one of my favorites. Yeah, that's a good show, right? Another comedy that people love that I don't have on here is The Good Place, which is coming into its 3rd season, I believe, which is a great show. But we also have classics, and this is where we get a lot of people coming, because some of these classics are on Hulu, but a lot of them are only on the NBC app. So we've got some from my childhood, Miami Vice. This one I especially love. Any of you in my demographic probably remember this fondly. We also have, excuse me. There we go, $6 Million Man, another fun one. We just got this actually, so we're really proud of that. And then a couple of shows we'd probably rather forget that we have. I didn't even know about Lipstick Jungle until I went there. And what's funny is these people have been, especially that lady on the right, I forget her name, but she's been in a lot of good shows. I don't know why she did this show, but like maybe they thought it was gonna work. But we do have it if you wanna watch it. And Charles in Charge, right? Scott Baio fans out there. All right, so let's get into like the tech stuff now that you know a little bit about NBC. Oh, I finally want to say we have one show that is actually exclusive and has never been shown on TV. Because did anybody have CISO like when it was out? CISO, the subscription comedy service? No one, right? I know no one did because it went bankrupt and NBC had to kill it. But it actually had some really good original shows on it. The one I really wanted was Paul Reiser's show from Mad About You. That went to Hulu, I think. But we got this one on Shrink, and this guy's, I think, on Comedy Central now, but it's a really good show, especially, I think, for people in this room that like look at NBC and think, that's kind of like mainstream stuff. Check this show out. I think you'll find it really funny. And what's surprising is it's kind of R-rated. I didn't even know we'd be able to show it like on our app. I was surprised, so, you know, it's kind of surprising. So we have this one. Check it out. This is what I'm here to talk about. So until now, all we had was basically editorial recommendations. So we have, excuse me, let me get some water. We had a whole team of people there doing editorial recommendations. We still do. We call them producers. And they each have a platform that they're responsible for, and they set up the homepage, and they change out the shows, and they put a big dynamic lead up top showing like what's hot and so forth. And this is sort of a game changer. I mean, I'm not so sure that we're friends. We're friendly, but this kind of approach is basically saying we don't need people to do that because we can do that with an algorithm. And so this is the new feature called Top Picks for You. You'll see it on the website. This is the website version. You'll see it on all the apps. You just have to watch one episode, and you just have to start an episode of something. And by the next day, you should have a shelf called Top Picks for You. And that should show up on any of the apps. So we have a Roku app, and we have all the mobile platforms, Xbox. So you can tell a little bit about me. I like comedy, obviously. Well, Will and Grace classic and original. I really do love Dateline, I have to admit. And the event is the kind of the curveball. I've never actually watched it, but just looking at the description, it does look like something I'd like to watch. So these recommendations are pretty good. So how do we produce these? There we go. If you think about the problem of recommendations, it's really the problem of solving this table, this matrix, right? If you have your users as rows and then your shows as columns, and our problem's actually a little easier. It's big data, but it's not gigantic data because unlike Netflix, we only have about 100 shows. So it's worth doing recommendations because people don't know we have these shows, but it's not the kind of problem that like Netflix has where their columns would be thousands, right? So our matrix, our table is roughly 100 columns times, it's in the tens of millions of users, but that's the table we're dealing with. If you fill in those question marks, then you know what to recommend, right? If you've got some kind of behavior, and this is just behavior, by the way, some kind of indication that the stars represent that the people like these shows to this degree, and you fill in the question marks in terms of what they haven't watched or haven't expressed an interest in, you know what to recommend, right? You just recommend the show that has the highest predicted ranking. So that's what we're trying to solve for. What about the fact that we don't have ratings? So I have this slide. I gave this talk at work, actually, to pitch the project, and I had to worry about it then, but nobody seems to care anymore. At the time, Netflix had just dumped their ratings, and they basically admitted that they're not that useful for predicting what people are going to like, because people rate content like documentaries really high, but they actually watch the Adam Sandler movies. That's why he keeps doing them. If you wonder, like, why do they keep paying him to do these movies? People apparently watch them. So yeah, who cares? We don't need ratings, right? Okay, so how do we get from the left side to the right side? And that's, and stop me if you have any questions, but that is clearly our task, right? So that's the math problem that we need to solve. I promise the math isn't too heavy on this. I'm going to show you a demo if I have time that is a little bit more math, but it uses matrix algebra, linear algebra, and basically if you've never taken that course, it's basically algebra, which everybody has taken, but instead of letters like x plus y equals z, imagine, instead of those letters representing numbers, imagine those letters representing tables. That's it. It's just algebra with tables. So that's why they call it matrix algebra or matrix multiplication, because it has tables instead of numbers. So matrix algebra is kind of weird. The one thing I want you to see here is these are two formulas. We've got one up top, which is a smaller table times a smaller table equals a big table on the right. And then the second kind of row down is a little bit bigger table times a little bit bigger table equals the exact same shape. So that's kind of interesting, right? I've increased my columns, I've increased my rows on the second one. My output is exactly the same. And I put one formula up there for the first cell in the upper left. And you can see it's just multiplying the C times the R plus the C2 times the R2. It's the same pattern no matter how many columns and rows. So actually it's pretty easy to do this multiplication. It's just a lot faster, obviously, for a computer to do it. So the thing I want you to notice is in this kind of a formula, matrix algebra doesn't care how many columns are in the first table or how many rows are in the second table. I'm still going to get that output on the right. The shape, I mean the exact same shape in terms of rows and columns. And if you think about it, that's what we're solving for, right, is that matrix. So how do we use this fact to do collaborative filtering? And again, this requires no metadata. I don't need to know anything about the content. I don't need to know anything about the user. I just need user IDs, shows, and some indication of their preference. So that's the math magic that we're going to work. So what we do is we break our ratings matrix, the thing on the right that we're trying to solve for, we break that into components. So we break it into the multiplication components we saw on the previous slide. So we have essentially a table on the left for our users, now has 2 columns, and the table on the right for our shows, which has 2 rows, and it produces the matrix we need. Now remember from the previous slide, we could have as many columns and rows as we want. Let's say we want 10 columns for the users. Now we are going to have 10 rows for the shows, but that actually works because when it comes to recommending content, it's all about what's in the content and then the preferences of the users for that type of content. If you think about it, I mean, it's kind of clinical, but you can break a show down to like, it's got this much romance, this much action, this much whatever, and then users have this much preference for each of those components in the show. So you can see in this example, I've just named these. The one is romance and one is comedy, and we've got for this first user, RP is romance preference, and the second one is comedy preference, and then for the show, this is us, romance content, and then comedy content. How much of it is in that show? If I multiply those factors together, I get that cell in the upper left, which is my rating in quotes for that user for that show. So I'll leave that up just for a second, just so you can let that sink in. Any questions so far? There we go. Okay, now our problem is we have question marks, right? We know that we can produce that problem on the right, where our question marks are, with these 2 tables, right? We've got the user table, we'll call it, and the show table. And I went ahead and filled in the rest of the variables. And we know that if we knew those 2 tables on the left, we could fill in every cell on the right, right? Because it's just a matter of multiplying the correct factors and adding them up. The problem is we have too many unknowns. We have less knowns than unknowns. So this is not the kind of formula that you solved at school at the bottom of the slide. So does everybody remember doing this at school when you get like x plus y equals 1, 3x plus 2y equals 4, solve for x and then solve for y? Right? Everybody remember that from for me, that was like 7th grade. Okay, I wish it was that easy, right? But we don't have enough knowns to solve for the number of unknowns. So what we do is we use a trick called alternating least squares. So how many people here have run just a very simple regression analysis, even in like Excel? Like a lot of people, right? That's like a real common technique. It's really cool. It just uses standard regression, but it uses it in a very interesting way, and it bounces it back and forth. I'll show you in the demo. And it basically fills in the missing values to the best fit that it can. So using the R-squared, fit measure of a regression, it alternates back and forth until it gets the best fit. So it gets you your best guess for those variables on the left that will result in the ratings that you actually know. So it looks at what's known and gets you, and that's the error measure, like your kind of R-squared. It gets you as close to those numbers as you can, because once you do that, you can then fill in all the blanks, right? And so I can show you, hopefully this time I'll show you a little demo on that. All right. So the one thing you do have to decide is how many factors. In machine learning parlance, that is your hyperparameter that you have to optimize. And so separately, you have to have a process for optimizing that. Is it 10 factors? Is it 2 factors? Is it 5? Is it 20? You would think that when I first started doing this and running, I thought, oh, the more the better, right? Because it gets very nuanced. But that's not true, because you may not have enough combinations of people watching enough shows to get that nuance. So the optimum number may not be 20, it might be 5. And that's even with like millions of people, which kind of surprised me. But maybe in the end, content can kind of be broken up into 5 big things, right? I mean, that's how we talk about it, like romance, action, drama, mystery. Okay, this was mainly when I was selling it at work, because I was like, let me do collaborative filtering. You guys know, you've probably heard of it, collaborative filtering is like the go-to technique. That's why I'm able to talk about it here, by the way, because we didn't do anything proprietary at all. This is just straight out of the box collaborative filtering. I use Spark machine learning, and I use the implicit rating algorithm, which is slightly different than the one I'm showing you, but it's basically the same thing. So there is nothing proprietary about this. So again, it was kind of a no-brainer project, right? Why not do it? And it does seem to be driving more views. Netflix did it. Spotify has confirmed they do it. There are other methods you can try. Some people say, why not do something else? And yeah, there's like content-based methods. And actually our director of product that does personalization is working with a lot of vendors on bringing the content side. So that's less interesting to me. It's a lot more interesting to her. Because that does help, things. You can get better recommendations, but the math is less, this is fun because it's all math, right? So for data geeks, it's more fun. You can also just do individual models for predicting each show. So you can do a random forest that says, for this show, what's your likelihood of liking it? And I'll run that model for every show before I give you recommendations. So some people do that. I haven't tried that yet. And if you guys are into this, there's even a conference for this stuff. Rexis 2018 is coming. It's their 12th year. So, enough people do this that there's a conference. I haven't been yet, but I would love to keep doing this kind of work because it's really interesting. All right, for the data engineers in the audience that want to know like architecture, like how do we actually pull this off? This is, again, not my area. I'm director of data science. There's somebody else there that's director of data engineering, a good friend of mine. But this is kind of the high-level architecture. It's all cloud-based, right? I mean, like everything now. So Amazon. We have Redshift, and then that feeds Amazon EMR. It also feeds into Databricks, which is the platform I just love. For any of you that are not data engineers that want to use like Spark, Databricks is just awesome because you can like configure clusters and set up jobs. It's all point and click. It's got the notebook interface very similar to Jupyter or Zeppelin. So we use that as well.
Are you using Delta yet?
No, but I'm fascinated by it. I was actually trying to sell our guy, because they're looking at Snowflake. I bet everybody's like looking at Snowflake, right? It seems like these platforms get really hot. Like, who here is looking at Snowflake? Yeah, it's like suddenly everybody's doing it, right? And I keep telling them, no, you got to look at Delta. Because I'm really sick of platforms that only do SQL, and then you got to get something else to do your data science. And Delta is the hope of the eventual like holy grail, right? Like, why can't I just do everything in one platform, right? And be fast. So yeah, I'm a big fan of Databricks because these are the guys that wrote Spark, right? And this is how they get paid. So it also makes you feel good to buy Databricks stuff because they're open sourcing all their code, right? Okay, just some examples. These are kind of old, but I think you can see I colored in like the themes. Like, you only need to watch one show. Like that first user, this is real data. She only watched Law and Order SVU, but we were able to predict some pretty good shows. I mean, that's pretty close. The Chicago shows are very similar. Christmas in Many Colors, I don't know where that comes from, but the more you watch, the better it gets. So you can see the people that watch more, there's more themes in there. This Is Us kind of goes with Days of Our Lives. Tony Bennett Celebrates 90 kind of goes with Michael Bublé and The Voice. So this is the cool part. When I saw this, I was hooked because I was like, I still can't believe like it has no idea like what this content is, and it's able to do pretty good recommendations. Future work. Oh, there. You stand closer. Okay. Future work that we want to do. I mean, it's become our biggest feature, so we're really happy, but we do have ideas. Mainly content stuff, which I mentioned already. Also, looking at different ways to measure user intent to watch. I just looked at like video starts, but maybe I should look at people that watched at least 25% or something like that. Machine learning work. Tuning the hyperparameters, I've got different ideas how I might do that. That's the more technical stuff, but you can always get better at that. And then optimizing the parameters. I'm currently doing grid search, so if somebody's like really into other ways to do that, come and tell me afterwards, because grid search takes forever. That's the other thing I love about Databricks, though. We spin up a cluster of like 200 servers and run it for like 5 days, and it optimizes just brute force. So that's the one nice thing of working at a place like NBC versus a startup I work where they have deep pockets, so you can spend a lot of money on Databricks. Okay, I want to show a demo now if I have, how much time do I have left? Perfect. Thank you. Perfect. I was thinking I might face like this. Is that okay? So, is that good? Yeah? Okay, so I want to prove to you guys that you can actually do this yourself with Excel. You can play with this algorithm. It's really fun to play with, actually. So I'm starting out with a really simple example where I've got 2 users, Scott and Bill, and 2 shows, and I only have 1 factor. So obviously this isn't realistic, but I want you to get how you write the formulas. And basically, you can see I've got a person vector in matrix language, because it's 1 column, and a content vector on the right. Those are those 2 tables like we had on the slides. And they multiply to produce the matrix on the bottom left down here. And I want you to just look at the green one, because that's the one that I've highlighted all across the sheet, right? So this green cell, S times T, Scott's preference times the this is us content, let's say it's like action or something, that produces that cell. And you can see we actually know already, we actually have 4 knowns here, so we have no unknowns. And then you can translate those 4 formulas into this situation as well. So is that kind of clear how that works? That's a really simple example. But then what you do is you translate that into a regression problem. And the way you do that is you take those formulas, which we have right here, and you basically set the data up like this. So I've got an S column, a B column, and then the dependent variable, or the output, which is 1. And there's my formula, S times T. And then basically, I do the same thing for each formula, and I initialize the T and the V. So I initialize either the user or the content with random numbers. That's the trick. So you either initialize the content or the users. The whole thing is just random numbers. So here I put random numbers for the T and the V, because I just have those 2 cells for the content table. And then you fill out the formulas. So you've got 3 and 2 here for T and V, 3 and 2. And so if we think about this, it looks a lot like a regression problem, right? So we can actually treat SB as independent variables, and then DB as our dependent variable. And then what the regression is going to do is solve for a single number, in regression problems would be like beta 1, that when multiplied by 3 and 2, right, this 3 and 2 here, it'll get as close as possible to the dependent variable, which is 1 and 2, what we're trying to predict. All right? So when you look at a regression problem, we normally think of beta 1 as the coefficient of S, right? But in this case, it's actually S. That's actually what we're looking for. Okay? And so then we just flip it. And so we'll solve for S, and I'll show you in the real demo like how that actually works real quick. It's already run, so it'll go quick. So this is kind of a real one, right? I've got some missing data. So the yellow ones, we don't know about those. We know about them, but we're going to hide them from our procedure, right? So because we've got 2 unknowns, we're only going to have 7 formulas instead of 9. So the 2 gray ones up there are unknown to us. These 2 here. And then we're going to break it into 2, drama and comedy, instead of just 1. So drama and comedy for the person, preference for drama, preference for comedy, and then how much comedy is in This Is Us and how much drama is in This Is Us, right? Drama, comedy. And so again, with the green, you see this upper left cell of 5 is produced by the green inputs, okay? Now here's a thinking problem. Forget about the math. Look at just the matrix in the middle, just this square matrix. Assume that we don't know the yellow ones. So we're going to solve for Joe's preference for blind spot and Sam's preference for blind spot. Who do you think we're actually going to get closer to? Like guessing correctly. Just looking at the data. Like who we have data on and what they watched. Who are we going to be about? What's the guess? Bill. Okay, why does someone think it's Bill? Interesting answer. Okay. And does anybody think it's not going to be Bill? Okay, now that we've heard the answer. Very, very good answer. So let's run through the regressions really quick. So again, it's set up the same way, and I'm happy to go over this in more detail with anybody afterwards if you want to. Set it up the same way as I showed you in the other one. I solved for the beta weights. I've initialized randomly on the right here. So T, V, M. So it's all initialized randomly, and then I'm solving for those basically. So, and then I ran the regression. This is your standard, like everybody's seen this in Excel. And you can see what I actually get out is the J, the S, and the B, the person variables. And then I flip it. So I take in the ones from the regression and put it over here. And then I solve for the other side, the content side. And I flip it, and I do the same thing, and I flip it. And notice the R squared. Notice what's happening. Are they getting better? Are they getting better? 4 9s. How about that? Why don't we stop there, huh? I mean, not stop. I got one more thing I want to show you, but let's stop alternating. But do you see how cool that is? Oh, okay. And then I just want to show you at the end that that person was correct, that our error measure for Bill was really small, minus 0.19, and for Sam, it was quite large. Now, with more data, obviously, we would be able to solve this better, but I hope that at least gets you an idea of how math really can figure out psychology, believe it or not. So thank you.
Any more questions for Scott? Questions for Scott?
Should I stand out there?
How many of you dream in Excel documents? All right, just kidding. Okay.
What's that?
We have a question over here. Oh, we're sitting.
Thanks. Scott, so I'm kind of curious about whether or not the actual algorithm for NBC is based purely on a collaborative filtering. Are there any weights that tie into programming where that influences if you have a show that leads a little bit more love?
Which is great. That's why I can talk about it.
Right.
So yeah, they have ideas in the future to like build in like, oh, we want to push this show, or we want to, and that's why this talk is well timed, because nothing proprietary or nothing that they would care is in there. We're just doing pure collaborative filtering, but they have tons of ideas, right? Because this was to really show that it worked, right? I come in and I'm like, hey, stop doing what you're doing, basically. And so this was to get them to realize maybe we need to change what we're doing. And now that they realize that, all those factors are coming into play. And so I probably won't be able to do this talk, you know?
Dark side.
Yeah, yeah. The money side is really what it's like. What shows do we get paid for, or what's the agenda? You know, a big company like that, it's like, which shows are we pushing, and which ones do we think are going to fail? So who cares, and you know, that kind of thing. So that's the stuff I definitely couldn't talk about.
All right, let's have a hand for Scott.
Okay, thanks.
We're out of time for questions.